بسم الله الرحمن الرحيم
शुरू अल्लाह के नाम से जो बड़ा मेहरबान निहायत रहम वाला है।
In line with its vision, the university is currently making a lot of progress to focus on developing science, engineering programs, capabilities and facilities in parallel to the Islamics, linguistics, humanities, social and management sciences. The Islamic Development Bank's funded Advanced Electronics Laboratories project is first ever international scientific grant at International Islamic University, Islamabad, and also first international advanced electronics specific grant in Pakistan. The idea is to support the efforts of the government of Pakistan in building the critical mass of skilled professionals and researchers in the field of advanced electronics. These laboratories developed by Professor Dr. Ahmed Shuja Sayyid are now available for teaching, training and conducting research work in semiconductors device modeling, sample preparation and subsequent characterization of devices, materials and system for real-time micro and nanoscale electronics for applications such as energy, sensing, communication and photonics and information security. The facility will be an open access to IIU students and faculty as well as other universities on an implementable working model devised by the principal investigator. Lawrence Berkeley National Laboratory, USA is a major collaborator to address the specific research and technical usage of the facility. A huge focus area of advanced electronic labs just in line with the international technology roadmap of semiconductors is to do with the scaling today's 22 nanometer chip down to eventually 7 nanometers by the end of the decade.
This lab has gotten huge impact in terms of the capacity building of this university, not just in the sciences and engineering capacities that I just elucidated to, but also to the Islamic Ummah. This is going to be, inshallah, a center of excellence for such research areas and such development areas that will contribute to the whole Islamic nation by basically having trained the manpower in the capacity building of such technologies, but also acting as a focal point for contributory technologies to spin off from the lab.
This research, for example, with the silicon CMOS energy efficient technology, will produce chips that are not only smaller and faster but use less power. This part of the lab's research will closely investigate the possibility on making such devices more efficient for next generation cloud computing and big data systems. The other areas focused in the ongoing studies include carbon and graphene nanoelectronics, silicon and 3-5 photonics, new memory technologies, and architecture that support quantum and, no surprise here, cognitive computing. Electronic Device Design Suite, this part of the laboratory, incepted in year 2010, is focused to facilitate students and researchers to design and model VLSI and ULSI devices, circuits, and systems. The design suite is equipped with state-of-the-art, trade-off commercial design tools. It is unique in a sense that it caters the concept of an electronic design house, where such facilities are available under one roof. Some of these tools are available in few universities in Pakistan here and there, but perhaps the concept of one window design suite is pioneered in International Islamic University, Islamabad. This is a mega facility aimed to train our future electronic engineers for global electronic design industry as well as address research problems in line with international technology roadmap of semiconductors. The laboratory is established with a keen, fabless approach.
This design suite is fundamentally a facility for graduate researchers, equipped with state-of-the-art IC design tools like Silvaco TCAD, Mentor Graphics IC design tools, Cadence IC design tools, MEMS Pro, STRIM, TRIM, SysPre, and COMSOL Multiphysics. Approach we are targeting here is the fabless solution to compete on international development arena technologically.
Process Characterization Suite. The primary objectives of this cross-cut facility are the development of metrology and characterization tools to support patterning, nano-engineered device processing, and overall integrated circuit fabrication and packaging for a variety of application areas. Electrical and electrophysical characterization. The characterization of electronic materials, devices, and circuits is incomplete without electrical measurements. AEL has a wide spectrum of electrical measurements and analysis techniques for device characterization. This includes capacitance measurements, current, impedance and resistivity measurements, and current, impedance and resistance spectroscopies with ultra-low ampere resolution at temperature between 77 K to 500 K and variable high voltages. Samples can be analyzed by direct probing on materials, devices, circuit, and wafer level using single probes or multiple probe cards. In addition, career lifetime measurements are available on substrates with microwave detected photoconductivity. Prober DC analysis, AC analysis, power and energy analysis, charge analysis, sheet resistance, activation energy, PCB characterization, IV, CV, GV characterization, and microwave, RF, and failure mode analysis. Nanochip reliability grade Hall effect system. This complete Hall effect measurement system using device probing supports a range of DC field Hall measurements, measures mobility on wafer scale materials and device structures as a function of temperature and field. Islamic. This highly specialized multi-technique electrophysical characterization system focuses on programs that address advanced characterization of device structures and front-end process to extend CMOS electronics to and beyond the 7 nanometer technology node, such as strained silicon germanium materials for high mobility MOSFETs, 3-5 MOSFETs, advanced gate stack technologies, advanced MOSFET structures, tunneling FinFET, and nanowires. Optical and electro-optical characterization. Optical microscopy and profilometry. Optical profilometry is a rapid, non-destructive and non-contact surface metrology technique such as reflected bright field, dark field illumination, polarized light, DIC, metrology grade spectroscopic ellipsometer, a fast CCD detector based SE in the UV, VIS, NIR range is featuring both fast data acquisition and full spectral resolution for process compatibility assessment and metrology for nanochip fabrication technology. The spectroscopic ellipsometer measures ultra-thin film thickness, refractive index, extinction coefficient, and related properties of bulk materials, single layers, and multi-layer stacks. Pre- and post-fabrication device and circuit level process optimization. MEMS grade spin coating, baking, and stirring. The high resist film thickness homogeneity as well as the short coating times makes spin coating the most applied coating technique, at least in microelectronics. High temperature electronic processing and synthesis facilities to facilitate the development and characterization of materials. AEL operates a general use computer controlled furnace facility with a variety of furnace types and temperature ranges. Nitrogen, CDA, and oxygen is provided by the facility and always available for use. Rapid thermal annealers are used for various applications for silicon, microchips, compound semiconductor, photovoltaic, MEMS, and other devices and systems. Atomistic Layer Evaporation System. NanoMaster NTE is a tailor-customized PC, control tabletop, ultra-thin fabrication-based evaporation system with wide ranges of application in organic or metal evaporation. Research in the interconnect and packaging with this tool is aimed at exploring and creating advanced technologies for connecting elemental on-chip devices to each other and to the macro world of chip, as well as novel techniques for integrating and packaging electronic components, including 3D stacked chip integration. Fume hood wet bench for cleaning, etching and sample preparation. Fume hood and wet bench in the lab are used to clean debris and to etch away unwanted or no longer needed films from wafers or device surfaces. Front end of line refers to the manufacturing process, the transistor portion of an integrated circuit. The hood in the lab is capable of making resist strip, nitride etch or strip, residue clean, post-etch or post-ash clean, oxide etch and shallow trench isolation clean.